Okay, so another series we need to make sure that we are familiar with is a p-series. So a p-series is going to look like 1 over n to the p. So n is your variable, and p is going to be some sort of number. So when you're trying to decide if this is going to converge or diverge, p is the thing that you are going to be looking at for this. So for it to diverge, p needs to fall in between 0 and 1, the 1 included. So if p is like 0.5, 1/3, 4/7, 1, whatever, any of those numbers, as long as p falls between 0 and 1, it is going to diverge. For it to converge, we just need p to be greater than 1. Now, one note that I really need to make, because I don't think I really did this in class the way I should have, is there is a special p-series called a harmonic series. The harmonic series is when p is equal to 1. So just this series, n equals 1 to infinity, 1 over n, is the harmonic series. The harmonic series is going to diverge because it fits in that range right there. I don't necessarily know that that wording will come up, but just in case it does, harmonic series is just a p-series where p is equal to 1. So kind of like we did with the geometric video, we're going to do the same thing here with p-series. Number 1 and number 2 are like your simplest situations. So when you look at number 1, we could rewrite this as the series from n equals 1 to infinity of 1 over n to the 1/2, because the square root is the same thing as the 1/2 power. P is 1/2. 1/2 is less than 1, so that means it's going to diverge. Now, it looks a little weird on number 2, but when we do some rewriting, that would just be like 1 over n to the 1/3 to the 5th. And since you have that power on the outside, it gets distributed to both things on the inside. So 1 to the 5th is just 1. When you have n to the 1/3 to the 5th, power to a power means you multiply. So 1/3 times 5 would give us 5/3. So 5/3 is greater than 1, so it's going to converge. So something like this is really when a p-series gets a little more difficult, is when you have to do a little bit like algebra to simplify it to make it look more right. Now, ones like number 3 and number 4 are probably more like what you would see if you're going to see it on the AP exam this year. Number 3 says find a range of values for p so that the series from 1 to infinity of 1 over n to the 7p will converge. So the first thing is to recognize that this does look like a p-series. And p in this series is equal to 7p. Well, the power is equal to 7p. I don't like the variables overlapping, but I can't fix it at this point. So for it to converge, we need p to be greater than 1. So we want 7p to be greater than 1. So solving for p means p is going to have to be greater than 1 over 7. If it was equal to 1 over 7, that would mean that the power was 1. That makes it the harmonic series, so it will diverge. But as long as it's greater than 1 over 7, so even like 2 over 7, if you put in 2 over 7, that makes it n squared. 2 is bigger than 1, it's going to make it converge. One like number 4, it says give a value of p so that 1 over n to the p diverges and 1 over n to the 4p converges. So the first thing to recognize is this and this both look like p-series. You have 1 over n to a power. So we want this first one to diverge. So that means p needs to fall in between 0 and 1. But we want the second one to converge. So that means 4p here needs to be greater than 1. So this one, you know it has to fall somewhere between 0 and 1 here. So if we solve this one, that just means p needs to be greater than 1/4. So if we want a number that's going to make the first one diverge and the second one converge, we need something greater than 1/4, but also less than or equal to 1. So let's say we pick P equals 1/2. If we pick P equals 1/2, the first one, 1/2 is less than 1, diverges, we're good to go. If we pick 1/2, 4 times 1/2 is 2. 2 is greater than 1, that means it converges. So P equals 1/2 is going to be a value that makes the first one diverge and the second one converge. So those should be kind of all the things you should see with the P series. Let me know if you need any help on anything.